TACACS Plus is a security protocol that provides centralized authentication, authorization, and accounting for administrators accessing network devices such as routers, switches, and firewalls. The plus in TACACS Plus indicates this is an enhanced version of the original TACACS protocol, offering improved security with full packet encryption and separated AAA functions. A network access control protocol is a security framework that verifies user identity, controls access permissions, and tracks user activities when accessing network devices. TACACS Plus operates as a centralized authentication system that separates the three core security functions: authentication to verify who you are, authorization to determine what you can do, and accounting to track what you actually did. This separation makes TACACS Plus particularly powerful for managing network device access in enterprise environments. Crucially, TACACS Plus encrypts the entire body of the packet, not just the password field. This complete session encryption ensures that all data, including the username and the specific commands being authorized, remains confidential during transmission. This comprehensive encryption is a significant advantage over the Radius protocol, which only encrypts the password. The TCP based communication also provides reliable message delivery and connection oriented security. Let's break down the key components of the TACACS Plus system. The network access device acts as a security enforcement point between administrators and network resources. When an administrator attempts to access a router or a switch, that same device, acting as a network access device or NAD, intercepts the login attempt and forwards all authentication details to the TACACS Plus server. The server can connect directly with an existing corporate directory services like Active Directory, allowing organizations to use their current user management systems. Administrator accounts contain specific settings which control what each person can access. These accounts can be set up with different permission levels. Some administrators might only view system information for monitoring, while others can make full configuration changes. This ensures each administrator gets only the access they need for their job. Now let's examine each phase in technical detail. The authentication process begins in step 1. When a network administrator attempts to connect to a network device, the network access device prompts for credentials. In step 2, the network access device sends a start packet to the TACACS Plus server via TCP port 49 containing the username, port information, remote address, and authentication type, all encrypted using the shared secret key. In step 3, the TACACS Plus server receives and decrypts the start packet, then validates the administrator's credential against its database, which can include local accounts or external directory services like Active Directory. If additional information is needed in step 4, the server can request it through interactive authentication using reply packets. The network access device then prompts the user for this additional data and sends it back via continue packets. Finally, in step 5, the server makes a definitive decision and responds with pass for success, fail for invalid credentials, error for server issues, and restart to begin with a different authentication method. For our example, we will assume authentication was successful with a pass response, so we can now move on to the next phase. Authorization determines what authenticated administrators are allowed to do on the network device. Authorization happens immediately after successful authentication. In step 6, the network access device sends an authorization request packet that includes the authentication method, privilege level, and the requested service or command, along with argument value pairs describing the requested action. In step 7, the TACACS Plus server evaluates the administrator's privileges and access policies, checking against role based access controls and command restrictions to determine allowed commands, session duration, and access level. In step 8, the server sends a response packet with its decision: pass add to grant access with additional restrictions, pass replace to grant access with replacing original request attributes, fail to deny access, or error for authorization processing errors. The response includes specific commands the administrators can execute and any restrictions. This level of detail is incredibly powerful. It allows organizations to enforce the principle of least privilege by controlling every single command an administrator can run. Accounting provides comprehensive activity tracking throughout the user session. In step 9, when a session begins, the network access device sends an accounting start request that records who logged in, when, and from where. During the session in step 10, the system can track every command executed, creating detailed audit capabilities for administrative activities. In step 11, when the session ends, a final stop request captures the complete session information, including duration and resource usage. This comprehensive accounting data is essential for security monitoring, compliance reporting, and forensic analysis when security incidents occur. TACACS Plus provides a security foundation for enterprise network device management through its strong authentication, detailed authorization, and comprehensive accounting capabilities. The protocol's separation of AAA functions and complete encryption make it the preferred choice for securing critical network infrastructure access. I hope this overview helps you understand how TACACS Plus secures network device access and why it is fundamental to enterprise network security. Thank you for watching, and I'll see you in the next cybersecurity video.